In the last session, we discussed the concepts related to Git, okay, Git installation, and here we have stopped the concept. So what are these folder names? Okay, so in the project, we have created, we updated the code, we committed the code. Once we have committed, we got some logs, we got some commit hashes. What is this commit hash and how we are going to work with those? How Git will store the data that we need to see today. Git log. When I give this, it is going to show you the commit which we have made. So this is the commit ID. So if you want to see that in a simple manner, in a single line, what you can do here is git log hyphen one line. When you give this, here you can see there is a commit ID and this is head. Head means nothing but it's a pointer where exactly the current user is accessing, on which commit the current user is working. So that will be shown by the head. Head is simply like a pointer on which branch the user is working and what is the commit ID. So that will be declared by the head. When you see here, there is a commit ID is there. So this is the commit hash. What does this commit hash means? So how Git will store the data? So Git stores the data as key value pairs. It is going to store the data in the form of key value pairs. So now what is a value here? Value is nothing but the actual content of your file, whatever the actual content is there. For me, this is the actual content which I have saved inside the file. And the key is nothing but the unique fingerprint. Unique fingerprint is nothing but this hash ID. So whenever you want to see what is the data stored inside this commit ID, then you have to provide. This is the key and associated value will be assigned to this hash. So Git doesn't remembers the files by name. So it is not going to remember the files by the names. So provider.tf, vpc.tf, it is not going to remember like this. It is going to remember the data, not the file names and associated hash. So it remembers the content by its fingerprint. I said, there will be, it is going to remember by the fingerprint or hashes. So that hashes are nothing but your commit IDs. Okay, what does Git actually do? For example, we are creating a file. So here I am creating a file called as vpc.tf. So inside that I have added some content. Git reads the content and ignores the file name. Git runs the SHA on the content and calculate the hash like. So here how you are going to see the hash ID. So like that it is going to calculate a hash and stores it internally. Internally how it is going to store? It is going to store like key value. So this is saved inside. Where it is saved? It is saved inside the .git objects folder. Inside the .git folder, we have an objects folder. Inside this, we will be having some folders are there. Inside these folders, you can see the data. So how I can see the data? Simple. Here you can see git cat hyphen file, git cat file hyphen p. You can provide this commit ID. When you provide the commit ID, it is going to show you the tree. So let us copy this ID. Let me, okay, copy this ID. And again, git cat hyphen file hyphen p. This is the tree ID. When I provide this, here you can see there is blob. Okay, blob is another object. Okay, inside the Git, blob is another object. Binary large object. The full form of blob is binary large object, where actually your data is saved. FVFC, this is the hash ID for your provider.tf. So which means that it is not saving the file, it is saving the content of that particular file. If you cat hyphen file, when I give the ID over here, blob ID. Okay. When I give the blob ID, it is going to show me the data inside that particular blob. What is the data that is present inside that particular blob? Only the content of the file will be preserved inside the blob. So if you see the hierarchy will be a commit, and under that we will have the tree, and under that we will have the blob. Whenever you do the commits, so these folders will be created inside which you will have the hashes. Now if I do another data change in this file, so let me add a resource AWS underscore internet gateway. demo igw. I have made some modifications in the file. VPC ID is equal to AWS VPC demo git dot ID. Okay, I will save this. When I save this, I have made some modifications. So if you see here, git status. So vpc.tf is modified. So I want to update that into the staging area. How I can do that? Git add vpc.tf and git commit -m added internet gateway to the VPC. Simply I will give like this. So it is committed. Now what is the commit ID? Git log -one line. When you give this, here you can see the new commit ID is there. What is that? Added new internet gateway to the VPC. This is the message. So if you see this commit ID, what will be there? Git cat -file -p. When you provide this commit ID, it is going to represent the see there. It is pointing to a parent tree, and as well as a new tree is created. Tree is representation of your folders. Okay, folders and subdirectories. So here, what is happening? It is pointing towards the parent. What is the parent ID? 26 before is there, no? If there is any change, just a simple change of data, if one letter is replaced, automatically the hash symbol will be, the hash will be changed. Whatever you are seeing, this is not the same parent hash. Why? Because we made a change. When we made a change, automatically the hashes of every object like parent, tree, blob, and as well as commit, everything is going to be changed. If I modify here, in place of IGW, if I give some GW, gateway, so then what will happen? Then we removed one word. When we remove one word, automatically what happens? The commit ID is going to be changed. Every hash will be changed. So that much particular the Git is all about. So here you can see we have the logs, and each log, the Git log, whatever you are seeing here. Inside this Git log, you will be having the commit ID. Inside the commit ID, you will have the tree ID. Inside the tree ID, again, you will be having the blob ID. Inside the blob ID, you will be having the actual data. So now if you see here, if you take this blob ID, git cat -file -p, when I provide the blob ID, when I provide the tree ID here, there are two blobs. FE is already, that is modified, so I don't need to check out what is there inside it. The new blob ID is this. So if I go for cat, git cat -file, I will paste it. So when I paste this, automatically what I'm going to get? I'm going to get the modified data. Internet gateway is the data that is stored. So if you want to check out the Git storage, you have to check the blob IDs, you have to check the commit IDs, you have to check the tree IDs. With those, you are going to understand that Git is going to save the data. Git will be saving the data in the form of key value pair, where key is the hash ID and value is nothing but the data that you have entered into the file. So this is how the Git will be storing the data. Next one, git diff command. So what is this git diff command? For example, here git, if I give it diff, the meaning is that what is the difference between the current command. So what is the current commit? So if I say git log -one line, so these are the two commits that we have made. So in the current commit, I just added the VPC. In the previous commit, I have added some Terraform files. Now, if I want to know what is the data that has been changed from the previous commit to the current commit, what I can give is git diff. When I give this, git diff head tilde. The symbol is called, the wave symbol is called tilde. And when I give 1, the meaning is that head means the current position, the current commit ID. Okay. Tilde means one step backward. It is going one step backward. So one step backward or two step backwards, depending on the number which you have provided. So I gave the one number. What is the meaning of one? One means one step, one commit back. So I have my head in this particular commit. So I want to know what is the data change that has been made one step backward. So that's why you can give this head tilde one. When you give this, here you can see this particular data has been added to the file. What is the file? vpc.tf. In vpc.tf, user has added certain data. So this particular data. So that is the difference between the current commit and the previous commit. So what is the difference between current commit and previous commit? If you want to know this, head tilde one. So if I commit it again, for example, I will go for I'll add few more data over here. I'll give like tags. I'm providing the name for the internet gateway. Name is equal to git-igw. So this is the name of the internet gateway. If you want to provide, or else if you want to create another resource, I want to create an AWS subnet, AWS underscore subnet, and the subnet name is demo subnet 1. And in which VPC you want to create this? VPC ID is equal to AWS VPC demo git.id. Just simply I'm writing some code, that's it. Okay. So cider block is equal to, I can provide like 10.20.1.0/24. I'm going to give like this. So I'll save this, for example. So after that, I can edit so many things. Here I have to provide the availability zone, name of the subnet, all I have to provide. But as of now, I will stop here. Now we have made certain changes in the file. So if you see the git status, modified vpc.tf is there. Git add. If I give dot, then what will happen? Whatever the untracked hello.sh is there no? That is also going to be added into staging area. So no problem. Git add dot, and what I will do? Git commit -m added subnet data in vpc.tf and added a file added hello.sh. If I give this, so the commit is done. So if you see the git log -1 line, when I give this, then what will happen? So there are 3 commits. Right now the head is on the 3rd commit. It is pointing to the 3rd commit and it is pointing towards the master branch. Okay, so now I want to see the data difference between the 3rd commit to the 1st commit. So between these two, I want to check the difference. So how I can check that? Simple. Git diff head tilde 2. When I give this, it will go back to the it will not go back to the previous commit. It will go back to the 2 commits backwards. It will go 2 commits backwards. Here you can see. So 2 commits backward, what has happened? So we have added the internet gateway and we have added the demo subnet. So which means that it is taking the difference between what I can say, it is taking the difference between 2 commit, between the latest commit to the what I can say 2 steps backward. Okay, so that is the meaning of this git tilde 2. If I give 1 means what happens? Git tilde 1 means it will go 1 step backward. Okay, so this is how you can find the difference between the, how you can find the difference between the commit, one commit to the another commit with the help of head and tilde symbols. One thing, and the other thing is, for example, if you are in the 20th commit, you want to know what is the data change that has happened from 10th commit to the 20th commit. Are you able to understand? So for example, here I will provide certain data, that is availability zone AP-south-1A, and then tags is equal to name tag. Tags is equal to name tag, that is equal to git -subnet -subnet-1. And when I save this, look at here. Again, I will go back here. Git status. git status. We have a modified vpc.tf file is there. Now what I will do, git add vpc.tf. Now it is in the staging area. If you want to find out the difference between the staging area and the previous commit, then what you can do here is git diff hyphen stage. If you give this git diff, one second. I forgot this. Git diff hyphen staged. I think staged it is. Only the D is the difference. I think that. One second. Staged. I gave stage, it is staged. Okay. Right. So if you give the command git staged, if you give the command git staged, it is going to show the output, like what is the difference between the, now currently the vpc.tf is in the staging area. So whatever the file that is there in the staging area, or else what is the data that is currently in the staging area, and you want to find out the difference with the previous commit. So then you can see git diff hyphen stage. When you give this command, what will happen? It will compare the staged files with the previous data, whatever it has been stored on the commit. So now here you can see it is clearly visible that we have added some data. So this is the data which is added. So right now that particular data is in the staging area. So that's why I have given git diff staged. And what I can do, git commit -m added complete subnet details. I just now committed it. So when I commit this, so if I want to check how many commits are there, git log hyphen one line. When I give this git log hyphen one line. So right now we are on the 4th commit. So I want to know the data differences between. So how much amount of data, what data we have added in between the 4th commit and the 1st commit. If you want to know that, what you can do is you can give git diff the 4th commit ID and as well as the 1st commit ID. If you give this 2 commits, then it is going to show what is the new data that has been updated between these 2 commits. Here you can give like this, git diff commit ID, the latest commit ID to the oldest commit ID. Then it is going to show you the data that has been stored between these 2 commits, the difference between the data that is stored in between these 2 commits. Right. So on the next one is, for example, I'm going to add one more subnet. I will be adding one more subnet over here. This is subnet 2 and 10.20.2.0 and it is AP South 1B and this is git subnet 2. Let me save it. So now once I have saved this, now it is in the working directory. So if you see, what is the meaning of this git status? Okay, it is not yet added to the staging area. The file is not yet added to the staging area and as well as it is not yet committed. So if I want to check the data difference between the working directory, the data in the working directory to the previous commit, then what I can do is I can give the command git diff. When I give the command git diff, it is going to show me the newly added data into that particular file. So what is the newly added data? This particular data has been newly added. So it is still not yet committed. So not at the file is not yet went into the staging area. It is still in the working directory. Once we have given the command git add and git commit, then it will be committed. And we can see the differences between those two. Like what I can say, the previous commit ID and to the latest commit ID, we can give the git diff head -1. So like that, or else -2, or else I can give git diff the commit ID, the 5th commit ID to the 2nd commit ID, or else the 1st commit ID. Then it is going to show you the differences. So in general, we are working with the git diff command to check the data storage, what is the previously stored data and what is the current stored data, what is the difference between these two data, that can be identified with the help of git diff command. Okay, git add vpc.tf and git commit -m added second subnet. Good. So now it is committed. So this is about your git diff command, and then we have seen the concept of what I can say, how data will be stored. And the next one is, for example, I want to rename a file. So how I can rename a file? Simply mv. Here we are having provider.tf. Here I am having provider.tf file is there. I want to rename it to main.tf. How I can rename that? mv provider.tf to main.tf. Now what Git will think here? So you need to understand this. I am renaming the file. What Git will think here is Git status. Look at there. Git is thinking that provider.tf is deleted and a new file main.tf is created. Are you able to understand? When I give the manually, when I am changing, when I am renaming the files, what Git is thinking here is the provider.tf file is deleted and a new file with the name main.tf is created. So that is what it is thinking. So it should not be like that. So we just renamed the file. We just renamed the file from provider.tf to main.tf. When I add it to the staging area, then Git will compare the data between these two files. So if you see git add dot or else git add dot. Now I have added all the files to the staging area. Now what I will do, git status. Now it understood. What it understood here is by checking the data in both the files. So provider.tf is deleted, but it is known by the Git. Okay, the data is there. And main.tf is also, it's an untracked file. Now it is comparing both the files, previous file and the current file. Then it understood that, okay, it is not the new file that got created. It is the file which it renamed. The provider.tf got renamed to main.tf. So that is what it will understand. But before that, what it is thinking that the provider.tf got deleted and main.tf got created, but it is not like that. Okay. So now what I will do, git commit -m rename provider.tf to main.tf. Now it is done. So renaming of provider.tf to main.tf is completed. So these many steps you have to do. So you can simply overcome all these steps by using a simple command called as git mv. Despite of giving mv, give the git mv main.tf to provider.tf. Now Git will understand, okay, the user want to rename the file. The user wants to rename the file. So directly the file will be renamed and automatically it will be sent to the staging area. Okay, if you see git status, look at there. Previously, when I renamed manually, it is telling that the older provider.tf is deleted and main.tf is created. And again, when I give git add, when I manually send it to the staging area, then Git understand that there is a renaming of files has been happened. So here it is not like that. When you give git move command, git mv command, automatically Git knows that, okay, the user want to rename the file. So I will rename the file and add it to the staging area. And then what I can do, I can simply give that git commit -m add or also rename main.tf to provider.tf. That's it. So done. So this is how you can rename a file. So whenever you are renaming the file, you must be very, very aware of what you are renaming and how you are renaming. Okay, so don't ever use mv command. So for renaming the files, you can use the command git mv so that you don't need to do anything manually. Manual mistakes won't be there. Okay, so this is the concept of renaming. And the next one is we have to go with the git restore option, git reset and restore option, but I won't say right now. We will discuss about the Git branching, and then we will go ahead into the topic of restore. So to understand the Git branching, let me tell you. Go to the Google Git visualization. Student dot, yeah, Git school github.io. So when you see here, come on, yeah. So whenever we initialize the Git, when we give the command Git init, by defaultly what happens? The Git will start with the master branch. When we do the commit, the first commit, so it will be this first commit, and then what we can do, we are going to provide the multiple commits. Git commit on the same master branch, we are going to commit it. The second commit ID will be there. Git commit, the third commit ID. Git commit, the fourth commit ID will be there. So like that, we will be doing the multiple commits. But it is not a recommended practice to make the changes in the master branch. Whenever you are working in any company, the company will not support you to do the work on the master branch. So the branches, what are the branches that we are talking? These branches will be like there are some feature branch will be there, bug fixing branches will be there. So like that, you are having different branching strategies are available. Develop branch will be there, and main branch will be there. Main branch will directly go into the production. Main branch will be directly going to the production environment. And whatever the developers want to do, so developers should not work with the main branch or master branch. They have to take a separate branch, and they need to do the changes in their code. So for example, it is a develop branch. Okay, develop branch where they will be developing whatever the code that has been developed by the developers, that code will be available in this develop branch. And if you are working with any features, okay, so now what you can do, so you can create a feature branch, not future, feature. Feature means any new modifications, any new icons, or else any newly you are adding any what I can say. So for example, previously we are having a mobile banking is there. For that, there is no biometric authentication. Now you are adding a feature to that. So that is a biometric authentication is a feature for that particular application. For example, voice messaging is not there. So you are adding the voice message to that banking application. Then that is a feature. So you can do all, you can add all these feature branches, features to the features in the feature branch. And if, for example, if there is a bug, okay, so the code, whatever the code that we are working with, the code is having the bug, and I want to check, then what you can do, you can go with the bug fixing branches. You can create another branch called as bug fixing branches. So you are not, so the developer is not allowed to touch the master branch until unless the entire code is properly working and it is ready to go into the production environment. So here you can see Git branching strategies. What are the different branching strategies that we will be having? Look at that. Here you can see main branch. This branch always contains the production ready and stable deployment code, which I have said you, master branch. Feature branch, developer creates a new or short-lived branch for new features, bug fix, and experiments. This isolates the ongoing work from the main code base until it is completed and reviewed. And then we will have the pull request and merge request. We'll discuss about that later. PRs and MRs. So first of all, you understand this branching strategy. If you go into this particular website, it will be showing so many other ways. So there you go: master branch, develop branch, feature branch, release branch, hotfix or bug fix branches. Hotfix means, so your application in the production environment. So the application is running inside the production environment. Suddenly there is an issue. Instantly you have to react for that issue. So you cannot work on the master branch. So what is the meaning? For example, if we have the entire code in the master branch, and this code, whatever the code that is in the master branch, that is sent to the production environment. Now suddenly we got an error, not error, there is a bug, or else you have to fix something. Now you don't have to take the code from the master branch. You have to taken another branch, separate branch of the same code base, and that branch is named as a hotfix branch, and immediately you are going to fix the bug, and you will be merging that code into the code back to the master branch. So this is called as hotfix branch. See that? Create from the master branch to address the urgent issues directly in the production. It helps in discovering the bugs smoothly, allowing the developers to continue their work on the develop branch while the issue is resolved. So like that, there are so many so many branch strategies are available. Just now we have discussed about a few: master branch, hotfix branch, release branch, and develop branch, and feature branch. So now whenever we are working, whenever we initialize the Git will be in the master branch. We are not going to touch it. Now what I can do here is I am going to create a new branch. How I can create the command is git checkout -b develop. So when I give this command git checkout -b develop, what will happen means a new branch called as develop will be created, and I will be moved, or else the user will be moved into that particular branch. So right now we are on the master branch. When I give this, so either new branch develop is created, and we just switch it to the develop branch. So here also the same thing will happen. Git checkout -b develop. So whenever we give this particular command, automatically if you see previously the head is at the master branch, but now the head is pointing towards the develop branch, which means that the user has moved to the develop branch. Here you can see that. Git log --one line. See that the head is pointing to the develop branch. Now what I will do here is I will make some commits in the develop branch. Git commit, and then git commit, and then git commit, git commit. So I did not make a single commit in the master branch. I did not make a single commit in the previous branch. Either it might be a master or any another branch. I did not make a single commit. Now what I will do, I will go back to the master branch. How I can go that? Git checkout master. When I give this command git checkout master, now where the head will be pointing, the head will be pointing to the master branch. So I did not make any single change in the previous branch. So here you can see this master branch is a previous branch, and develop branch is the newly created branch. And I did not make a single change in the master branch. As I did not make the single change in the master or single commit in the master branch, when I merge these two branches, when I merge the develop branch and the master branch, then what will happen? Git merge develop, which means that I am combining I am combining the development branch code into the master branch. So if I go for this, then here you can see this type of merging is called as fast forward merging. This type of merging is called as fast forward merging. If you are having a new branch and you are making the commits only in the new branch and not even touching the old branch, and you want to merge the new branch with the old branch, then that type of merge is called as fast forward merge. Okay, so now what we will do, let us see what is meant by fast forward merge. So in the develop branch, what I will do here is I will add some data. I'm not going to touch the master branch. I'm going to add some data. Demo subnet 3, and this is 3.0, and this is AP South 1C, and demo git subnet 3. Now what I will do in the develop branch, I am going to git add, git commit added subnet 3, added subnet 3 code, and then if you see here git status git log one line, look at that, master is at the previous commit only. What is moving? Head is moving towards the develop branch, and in develop branch we have made a commit. Again I will go ahead and create one more subnet 4. This will be AP South 1A and git subnet 4. Let me save this. and again I will do the commit. Where we are doing the commit in the develop branch we are doing. We are not touching the master branch now. Git add dot git commit subnet 4 is added. Okay, git log one line. So now the head has been, the develop branch, the new commit is created and head has been, the pointer has been moved to that particular commit. And here you can see we are not even touching the master branch. Now what I will do, I will go back to the git checkout master. We are switching back to the master. I want to merge git merge develop branch. I want to merge the develop branch. So when I merge it, which type of merging it is? It is a fast forward merging. Okay, if there is no commit happened in the previous branch, if you are doing the commits only in the current branch, and if you want to merge the current branch with the previous branch, then that is called as fast forward merge. Okay, so if you see git log hyphen one line hyphen graph, when you give this, it is going to show you the graph. Okay, so what are the commits that has been made and where the head position is. So this is what we call it as a fast forward merge. Do you understand the topic here? What is meant by branching and what is meant by merge and what is a fast forward merge?
But in the master branch, we did some commit before, right?
Before we did,
Before creating the develop branch.
after creating
After creating the develop branch, we didn't
we didn't do any
commit.
commit, no. So then when we merge the develop branch with the master branch, then that is called as a fast forward merge.
Fast forward. Okay.
Okay. Now there is another type of merge, that is recursive merge. So what does this recursive merge means? For example, now there is a develop branch. No, I will create a git. We can create a branch with the command called as git branch feature. Git branch feature. So now if you see git branch, it is going to show you the feature branch is also created. Here you can see the feature branch is created. Okay, so if you want to create only a branch and if you don't want to log in or check out onto that branch, then you can simply give the command git branch feature. No, I want to create the branch and automatically the user should be shifted onto the branch. Then what you can do here is you can give the command git checkout -b feature. When I give this, then what happens? Previously, if you see in the command line, what you have seen, the feature branch is created. Git branch means the feature branch is created, but the user is still in the master branch only. But when you give the command git checkout -b, then what will happen means the branch will be created and the head position will be moved to that feature branch. Look at that. Now the head is associated with the feature branch. Now what I will do, git commit. I'm doing some commits in the feature branch. Git commit. Okay. Now what I want to do here is I want to check out to develop branch. So the feature preparation is completed. Inside the code, whatever the new feature that you want to add, that particular code base is created. Now you want to merge the feature into the develop branch. So before you thought merging of the feature into the develop branch, what develop branch, in develop branch, a few commits are happened. Git commit, a few commits are happened in the develop branch. Now what you want to do, you want to merge the feature branch into the develop branch. The feature is completed. Whatever the manager said you to develop the feature, the development of that particular feature is completed. Now you want to merge that feature branch into the development code base. Then what you can do here is git merge. We are in the develop branch only, no? So the head is pointing towards the develop branch, which means that currently the user or else the head is in the develop branch. Git merge feature. When I do this git merge feature, what happens here is a new recursive merge will be created. A new commit will be created. So here you can see what happened. we are making some commits in the feature branch. At the same time, we made some commits in the develop branch. Now I want, after creating the feature branch, I made some commits in the develop branch. Now what I want to do, I want to merge this feature branch into this development branch. Then what happens here means a new merge will be generated. To merging these two branches of two different code bases, we are going to get a new recursive merge. So here you can see a new commit ID is created so that this feature branch is now merged into the development branch. So to show you that, git checkout feature. Right now we are on the feature branch. What else I can do here is I'll create a route table. Route.tf resource AWS underscore route underscore table. And this is demo route and the VPC ID is equal to AWS underscore VPC demo git dot ID. And then tags is equal to name tag, that is what I can say, git public RTB, git hyphen public hyphen RTB. So I'll save this. Now when I do this changes in this, git add, git commit added the route.tf file and added the RTB routing table where we are making the changes in the feature branch. Again, I am going to commit it. Again, I am going to do some modify some data. Root gateway ID is equal to AWS Internet Gateway dot ID. We need to add the gateway, and then cider block is equal to the meaning you will come to know 0.0.0.0/0. We have added another feature, or also not feature. We made some changes in the data. Now again, what I will do, git add, git commit, added root for internet access in route.tf. Done. So now in the feature branches we have made the changes. Now what I will do, I will switch back to the develop branch. Git checkout develop git checkout develop branch. In the development branch, what I can do here is in the vpc.tf I'm just going to add one commit. I'm not going to do anything more than that. Demo 5, and this is my fifth. JP South one is fine, and the name is 5. I'm going to give like this, and I'm going to make a commit in the develop branch. So git add dot, which means that I'm adding all the files. Git commit hyphen m added subnet 5, and so now the commit is done. So if you see git log hyphen one line, look at there. So we have the right now we are in the develop branch. So develop branch doesn't know there is a feature branch. Now if I check out to the feature branch, what will happen? Git checkout feature. If you see, so it is showing only about the feature branch. So feature branch doesn't know the exact concept of develop branch, and develop branch doesn't know the feature. So we want to merge these two branches. How I can merge that? Git checkout develop, and here git merge uh, feature. I'm merging the feature branch. So here what will be happening means a separate data will be opened. So merge branch feature into develop. So we are merging the branch feature into the development branch. Please enter the commit message to explain why this merge is necessary. Explain especially if the merge is an updated upstream into the topic branch. So you can simply close this. So you can read this commit message. If you want to change, this is the commit message. Merge branch feature into the develop branch. So how you are getting the commit messages, how we are writing the commit messages over here, add a route.tf in the same manner. Here it is a commit message. If you want to modify this message, you can modify it. But as of now, I will close this file. When I close the file, then what will happen? Merging will happen. So waiting for you, for your editor to close the file. So I'm going to close this file. When I close the file, the merging will happen. The merging will merge made by the ORT strategy and route.tf. So the feature branch is added into the develop branch. How I can show you? Git log hyphen hyphen one line hyphen hyphen graph. Look at there. So this is a linear fashion that we are going. So from the master branch, we took the develop branch. So this is the develop branch, and we made some commits in the develop branch. And from the master branch, there is one more branch that is deviated, that is called as feature branch. In the feature branch, we have made it a few more commits. And when we are trying to merge these two, when we are merging the develop branch to the feature branch to the develop branch, what is happening? A new merge is added. So this is called as recursive merge. And tomorrow we will discuss few more Git commands